Good day, everyone. Welcome to my new website, which is Terry Learning. Right. So what I'm going to be looking today is the solution to the second question in the January 2020 physics paper. Right. So just a reminder for those of you who don't know me. I am the official author of the study guides for CAPE Physics Unit 1 and 2, right? Currently, I do not have a Form 4 class at home right now. I have a Form 5 class, right, that I'm wrapping up. They are writing exam in May 2020. This class is every Saturday from 9:30 to 11:30. We have completed the syllabus and we are doing past papers at the moment, right? So if anybody is interested, I'm located in Union Hall, San Fernando. You can WhatsApp me at 784-2059. This is specifically for Form 5 students only, right? Later on in the year, I will be launching a Form 4 class, but this class will be completely online, right? Students will get access to my website and they will get access to all my test engines to be able to answer any type of questions that they may ask at CSEC Physics. Okay, so moving on to the paper. This is question 2 in the the January 2020 paper. So in this question, they ask you to do several things. The first part is to define each of the following terms. So the first term that they want us to define is specific heat capacity. Now, specific heat capacity is the amount of energy required to increase the temperature of 1 kilogram of a substance by 1 degree, right? Now, when you are given definitions in physics, you need to be very precise. So it's the amount of energy required to increase the temperature of 1 kilogram of a substance. You need to indicate 1 kilogram in order to get the mark of a substance by 1 degree. That 1 degree can either be degree Celsius or it can be degree Kelvin, right? Because a change in temperature of 1 degree Celsius is the same as a change in temperature of 1 degree Kelvin. Now, the second part now, they want us to define specific latent heat of fusion of ice. Now, the specific latent heat of fusion of ice is the amount of energy, the amount of energy required to convert 1 kg of ice into 1 kg of water without a change in temperature, right? Now they ask you for the specific latent heat of fusion of ice, right? So we're talking about we're taking ice, right? So this is ice, and the ice is at 0 degrees Celsius, and we are converting this ice into water, right, at 0 degrees Celsius, right? So that's why we say without a change in temperature. Now with this definition, they ask you for the specific latent heat of fusion of ice. So you need to give the definition in relation to ice. So it's ice at 0 degrees Celsius being converted into water at 0 degrees Celsius, right? All definitions need to be very specific in physics. Now the next part, we have a calculation. So we have a block of ice, has a mass of 2.5 kg, and the temperature is minus 10 degrees Celsius. And you place this ice in a container, right? And they've given us certain pieces of information. They've given us the specific heat capacity of water, the specific heat capacity of ice, and the specific latent heat of fusion of ice. Now, the thing is, in thermal physics, you will encounter, there are two formulas that we usually use. One is mc delta theta, and the other equation is equal ml. Right? Now, mc delta theta is used when we have to change the temperature of a substance, right, without a change in state. Whereas we use equal ml when we have a change in state. So for example, if a solid is going into a liquid, we have to use equal ml. If a liquid is going into a gas, we need to use equal ml, right? But if we are just doing a change in temperature, we have to use equal mc delta theta, right? So the first part, we have, they want us to calculate the energy required to change the temperature of ice at minus 10 into, right, so all we're doing here is increasing the temperature of the ice. So we have ice at minus 10 degrees Celsius, and we're converting that into ice at 0 degrees Celsius, right? So we have not undergone a change in state. So we must use the formula E equal mc delta theta, right? Where m, they told us the mass of the ice, it is 2.5 multiplied by C, but we have to use C for ice, the specific heat capacity for ice, which is this figure here. So that is 2.1 by 10 cube multiplied by my change in temperature. I'm going from minus 10 degrees to 0 degrees Celsius, so therefore my change in temperature is actually 10 degrees Celsius. Alright, so if we work that out in our calculator, we're gonna get 52,500. So we're going to get 5,500 joules, right? You can leave your answer in this form, or you can write it in standard form. It doesn't matter. All right. So this is the answer for the first part. Now let's look at the second part now. They want us to calculate the energy required to convert all the ice at 0 degrees to water at 0 degrees. So we have ice. Right, the ice is at 0 degrees Celsius, and we want to convert that into water at 0 degrees Celsius, right? In this case here, what we are doing is we are changing state. So if we are changing state, we must use the formula E equal mLF, right? Where m, the mass of the ice, was 2.5 kilograms multiplied by LF, which is the latent heat of fusion of ice. They gave us that. That is 3.3 by 10 to the 5. So that is, so you're multiplying, this is 3.3 by 10 to the 5. Alright? And when we work that out, we're going to get 8.25 by 10 to the 5. So this is 8.25 by 10 to the 5 joules. Right? Our unit in this case is joules because we're talking about energy. Now, part C now. They said the water in the container is now heated to a temperature of 80 degrees by an electrical heater in 600 seconds. Calculate the power output of the heater. So we had water. The water was at 0 degrees Celsius. And we're converting that water into water, sorry, we're increasing the temperature of the water to 80 degrees Celsius, right? So the first thing we need to do, we need to find the amount of energy required to do that. So in order to find that energy, we have to use E equal mc delta theta. So again, it's 2.5 kilogram of water we're dealing with. We're looking at the specific heat capacity of water, which is 4.2 by 10 cube. So this is 4.2 by 10 cube multiplied by my change in temperature. I'm going from 0 degrees to 80 degrees, so my change in temperature is 80 degrees. right? So what this is given me, this is given me the amount of energy required to increase the temperature of the water to 80 degrees. So that is 8.4 by 10 to the 5, 0.4 by 10 to the 5, and this is joules, right? So that's the amount of energy required to increase the temperature of the water from 0 to 80 degrees. Now we haven't worked out the question as yet, because the question is asking for the power output of the heater. Now we have a container, right, that has water, and the water is at 0 degrees C, and you have an electric heater here, right, that is supplying heat to the water, right? Now the other formula we're going to have to use is energy is equal to power multiplied by time. In this case, we know how much energy is required to increase the temperature of the water. We just worked that out. That is 8.4 by 10 to the 5 joules. My power, we don't know what the power is. That's what we're trying to find out. And my time, it is 600 seconds. Now, please remember when you're using this formula here, time has to be in seconds. So sometimes you see exam questions where they give you 10 minutes. You need to convert it into seconds. So my power is 8.4 by 10 to the 5 over 600. So therefore power, right, will give me 1400 watts. Right, so this is 1400 watts, right? Just remember the unit for power is watts. Okay, and the last part of the question, state one assumption which must be taken into account in C part 1. Well, the assumption is all the energy supplied by the heater is absorbed by the water, alright, because that is what we use in the calculation. We assume that all the energy supplied by the heater is absorbed by the water. So truth and in fact, what we are saying is that no energy or no heat energy is lost to the surroundings. Alright, so that's it. That's the solution to question 2.